Hello 8th graders and happy Thursday. Tomorrow you're going to take your Unit 2 test, so today we're going to review. You're going to do a great job. Let's dive right in so you get lots of practice. Let's start on our do now. The two triangles are similar. What is the value of x? First, what's the scale factor to move from the triangle on the left to the triangle on the right? It's 2. The scale factor is 2. So what's the value of x? Well, I can multiply 15 times 2. When I do that, x is 30. Now try another. Is figure C a dilation of figure A? How do you know? Figure C is a dilation of figure A. All of the sides have been multiplied by a scale factor of 2. Now let's draw a dilation of a triangle with a scale factor of 1/4 and a center of dilation at R. So R won't move, and there will be a reduction towards R in straight lines. First, what's the original length of RS? It's 16. What's the original length of RT? It's 4. If I multiply by the scale factor of 1/4, what's the new length of R prime S prime? Well, 16 times 1/4 is 4. What's the new length of R prime T prime? It's 1. Go ahead and draw the dilation now. Check to see that your dilation looks like mine. Now let's find the slope of a line that passes through 4, 5, and 8, 7. Remember, slope can be found by subtracting y2 minus y1 over x2 minus x1. y2 is 7, y1 is 5, x2 is 8, y2 is 4. What's 7 minus 5? It's 2. What's 8 minus 4? It's 4. When I simplify that fraction, what is the slope in simplest form? It's 1/2. Now let's find the missing angle in a triangle. Remember, all of the angles in a triangle add up to 180 degrees. So I can start by adding 97 plus 47. What's 97 plus 47? It's 144. Now I can subtract from 180 to find my missing angle. What's 180 minus 144? It's 36. X is 36. Now let's find the measure of angle x for number 6. First, what is the relationship between those two angles? Those two angles are alternate interior angles, so they are congruent. X is 48 degrees. Today we're going to review for our unit test by going over some of the skills that we've learned in this unit. One of the first things that we did was dilate shapes, about a point and about the origin. Let's start by dilating about a point. Draw the dilation of the quadrilateral with a scale factor of 3 and a center of dilation at S. So all of the points are going to expand away from S in straight lines. First, what's the original length of ST? It's 3. What's the original length of SR? It's also 3. When I dilate by a scale factor of 3, I can multiply all of the side lengths by 3. So what's the new length of S prime T prime? It's 9. What's the new length of S prime R prime? It's also 9. Go ahead and draw the dilation of the figure now. Check to see that your dilation looks like mine. Now let's draw another one. Draw the dilation of the triangle with a scale factor of 1/4 and a center of dilation at A. This time we're going to be reducing the triangle along straight lines away from A. What's the length of AB? The length of AB is 16. What's the length of AC? The length of AC is also 16. When I dilate the shape by a scale factor of 1/4, what will be the new side length of A prime B prime? What's 16 times 1/4? It's 4. What will be the new side length of A prime C prime? It will also be 4. Go ahead and draw the dilation of that figure now. Check to see that your dilation looks like mine. We also talked about dilating shapes about the origin. Draw the dilation of the quadrilateral with a scale factor of 2 and a center at the origin. First, let's write the original ordered pairs for S, T, U, and R. What are they? S is at -1, 2, T is at 2, 2, U is at 2, -1, and R is at -1, -1. Now, what will be the new ordered pairs after the dilation? Multiply each ordered pair by 2. S prime will be located at -2, 4. T prime will be located at 4, 4. U prime will be located at 4, -2. And R prime will be located at -2, -2. Go ahead and draw those points in to show the dilation on your paper. Check to see that your dilation looks like mine. Now let's draw another. Draw the dilation of the triangle with a scale factor of 1/2 centered at the origin. First, let's find the original ordered pairs for A, B, and C. Go ahead and put those in now. Point A is located at -8, -8. Point B is located at -8, 8. And point C is located at 8, -8. Now, to draw the dilation, we need to find the new ordered pairs after a dilation by a scale factor of 1/2. So multiply each ordered pair by 1/2. What's the new location of A prime, B prime, and C prime? A prime will be located at -4, -4. B prime will be located at -4, 4. And C prime will be located at 4, -4. Go ahead and draw the dilation on your paper now, then check it with mine. Check to see that your dilation looks like mine. Tomorrow, you may be asked to draw the dilation of a figure. We also talked about similarity. Two figures are similar if one can be mapped to the other using a dilation and other rigid transformations. Similar figures have sides that have been scaled or multiplied by the same number. Similar figures also have congruent angles. The angles do not change. So let's look at an example. The two figures are similar. First, what is the scale factor to go from the figure on the left to the figure on the right? It's 2. Now, to find the angles, I can see which angles correspond, and I know those angles will be congruent. Angle A is 45 degrees. So what is angle I? It's also 45 degrees. Angle K is 50 degrees. So what is angle L? It's also 50 degrees. Angle O is 85 degrees. So what is angle M? It's also 85 degrees. The angles in similar figures are congruent. What is the length of side ML? Well, I know that I can multiply side OK 4 by 2 to find ML. So what's ML? It's 8. 4 times 2 is 8. What's the length of side IL? I know I can multiply the length of side AK 5 times 2 to find IL. Side IL is 10. Now you try a few. Triangle ABC is similar to triangle MNP. What is the scale factor? Well, to go from 15 to 5, The scale factor is 1/3. So what's the value of x? Well, 12 times 1/3 is 4. What's the measure of angles M, N, and P? Well, if angle A is 30, then angle M is 30. If angle B is 90, then angle N is 90. And if angle C is 60, then angle P is 60. Now you try this problem completely on your own. Trapezoid DEGF is similar to HJKL. What's the scale factor? What's the side length of LK? And what is the measure of angles H and K? The scale factor is 2. 5 times 2 is 10. The side length of LK would then be 10 times 2, which is 20. The measure of angle H is 105. It corresponds to angle D. And the measure of angle K is 75. It corresponds to angle F. We also talked about how we can use the ratio of the side lengths in similar triangles to find missing sides in another similar triangle. Let's look at these two triangles. They're similar. What's the value of x? It's going to be hard to find the scale factor between 5 and 7.35. So I can use the ratio of the sides. I know that the ratio 5 over 10 is going to be the same as 7 and 35 hundredths over x. 10 is 2 times as much as 5, so I can multiply 7 and 35 hundredths times 2 to find x. What's x? X is 14 and 70 hundredths. Let's do a similar problem. The two triangles are similar. What's x? This time I can use the ratio 5 to 15 to help me solve for x. I know that 15 is 3 times as great as 5, so I can multiply 7 and 35 hundredths times 3 to find x. So what's x? In this case, x is 22 and 5 hundredths. Now you try one. Use the ratio between the sides to figure out the value of x. X is 3 times as great as 2 and 4/10, so the value of x is 7 and 2/10. We also found slope in this unit. Remember, the slope of a line can be calculated by writing the vertical change over the horizontal change. Let's do a few examples. To find the slope of this line, we can start by looking at the vertical change. What's the vertical change? It's 1, 2, 3. What's the horizontal change? It's 1, 2. So the slope is 3/2. Now let's look at another line. I can find two perfect points on the line to help me find the slope. With the two perfect points I've selected, the vertical change is 1, 2, 3, 4. The horizontal change is 2, so the slope is 4 over 2. To find the slope as a whole number, proper fraction or improper fraction in simplest form, I need to divide. What's 4 divided by 2? It's 2. The slope is 2. Now you try a couple. What is the slope of each of these lines? First, what's the slope of the first line? The slope is 1. Now you try another. What's the slope of the second line? The slope of the second line is 1/4. The last skill we talked about in this unit was writing an equation for a line. Remember, slope is the steepness of a line or its rate of change. It's represented by the letter m. Slope can be found by dividing the vertical change by the horizontal change and writing the result as a fraction. We can use the formula m equals y2 minus y1 over x2 minus x1. The y-intercept is the y-coordinate when x is 0, or the point where the line crosses the y-axis. It's represented by the letter b. The slope of a line can be written in slope-intercept form, y equals mx plus b. To find the equation of a line, we can find the slope and then plug in x and y to solve for b. Let's do an example together. What is the slope of this line? I can see a perfect point at 0, -9, and at 1, -5. To move between those 2 points, the vertical change is 4, and the horizontal change is 1. So what's the slope? It's 4. M equals 4. What's the y-intercept? What's the point where the line crosses the y-axis? It's -9. B equals -9. So now I can write my equation. Go ahead and fill it in. What's the equation for this line? It's y equals 4x minus 9, or y equals 4x plus -9. We also learned how to do this with 2 points. Remember, I can start by labeling x1, y1, x2, and y2. 1 is x1 and 4 is y1. 2 is x2 and 6 is y2. I can find the slope by subtracting y2 minus y1 over x2 minus x1. Go ahead and find the slope. The slope is 2. Now I can use the slope to solve for the y-intercept. So I can plug in 4 equals 2 times 1 plus b. Or 4 equals 2 plus b. What's the value of b? B is also 2. So now I can write the equation of my line. Y equals 2x plus 2. You've done a great job with this video. Now it's time for practice. Go to tinyurl.com/practice927.